Today, we're diving into a really critical and kind of sneaky flaw in how a lot of AI agents are built. It's a flaw that can cost thousands of dollars before the AI even gets to its first task.
Yeah, seriously. This isn't just some hypothetical. It's a very real problem that comes from how we get AI agents ready to interact with their tools. A ton of systems are paying this massive hidden cost just to be on standby.
And this is the number at the heart of it all: 47,000 tokens. That's how much can be burned just to initialize an AI agent. This happens before you give it a single prompt, before it's done anything useful at all. It's just pure wasteful setup. So, where in the world does this huge upfront cost come from? Well, to really get the solution, we first have to unpack the problem. And it all boils down to how we've traditionally taught AI agents to use their tools.
Okay, so here's the core issue. The old school method is to load the entire definition for every single tool the agent might possibly use right into its context window from the get-go. So if you've got 60 tools ready to go, all 60 get loaded, even if the task only needs one of them. It's like handing a chef an entire library of cookbooks just so they can look up a recipe for toast. It's just overkill.
Now, at the center of this whole process is a really powerful protocol. And if you understand this, you'll totally get why the solution we're about to look at is such a game changer.
It's called the Model Context Protocol, or MCP for short. What's brilliant about MCP is that it creates a single standard way for an AI agent to talk to the outside world, whether that's a file system, a database, or some web API. It's basically a universal adapter. Now, the protocol itself is powerful, but the way it's been used, well, that's where the inefficiency creeps in.
And that brings us to the solution. It's a complete shift in thinking, really. It's about moving away from preparing for every single possibility up front, and instead, embracing a much more dynamic, on-demand way of doing things. So let's put it side by side. The old way, static loading, just dumps everything into the context window at once. That's our 47,000 token problem. The new way, dynamic discovery, is totally different. The agent starts with almost no tool information and only goes and gets the specifics for a tool at the exact moment it's needed.
And this new philosophy is powered by a tool called MCP-CLI. It's super lightweight and fast. It compiles to a single file, which makes it incredibly easy to deploy. And it was built from the ground up for AI agents to use in a command line environment. This is the engine that makes the whole dynamic discovery thing possible.
So, how does an AI agent actually use this thing?
Well, the process is actually incredibly simple. Instead of that one massive data dump, it's now just a quick, three-step conversation.
The workflow is just so straightforward. First, the agent discovers what tools are even available with a quick search. Then, it inspects the one specific tool it wants, learning its rules. And finally, it executes that tool with the right info. Discover, inspect, execute. It's just an elegant and way more efficient process. Let's walk through a real example. Say the agent needs to do something with a file. It doesn't know the exact tool name, so its first move is to discover its options. It just runs a simple command to search for any tool with file in its name.
Okay, so the search results pop up and it sees the read file tool. Perfect. Now it needs to know how to use it. So it runs an inspect command on that one tool. And what it gets back is a tiny bit of JSON, the schema, that tells it exactly what it needs to provide, in this case, a file path.
And finally, with that schema understood, the agent executes the tool. It provides the right arguments in the right format, and the job gets done. The whole thing used just a tiny fraction of the tokens that static loading would have, and it only happened right when it was needed.
Now, this beautiful workflow is only possible because of a very deliberate design philosophy. The real magic here isn't just the 3 steps, but the underlying architecture that makes it all so incredibly efficient. The entire system is what you'd call lazy by design. Connections to tool servers are only open for the split second a command is running, and then, bam, they're closed. If it needs to talk to a bunch of servers at once, it uses a smart worker pool so it doesn't crash the system. It even has built-in retries for network glitches. It does the absolute minimum amount of work necessary at every single step. And the payoff for this lazy, on-demand approach is huge. We're talking a dramatic reduction in token use, which directly translates to lower API costs. Plus, the leaner system just gives developers way more flexibility to build and scale their AI agents. It's a win-win-win. And really, the trade-off is a no-brainer. You swap one giant, expensive, context-stuffing operation at the very beginning for a few tiny, almost instantaneous command line calls during the actual task. It's a trade that pays for itself over and over again in pure efficiency and cost savings.
So, when you step back, you see this is more than just a clever utility. It's a whole new philosophy. The key insight is that building scalable, cost-effective AI systems means we have to think just as hard about how an agent gets ready for work as we do about the work itself. Interacting with the world on demand is just vastly more efficient than trying to understand everything all at once.